learners! Good day! I welcome you all to General Mathematics class. I am your teacher, Mrs. Marjorie A. Lagang, joining you today as I bring you an exciting lesson about inverse of one-to-one function. At the end of the lesson, you will be able to first illustrate the inverse of one-to-one function. Second, you're gonna solve the inverse of one-to-one function. And third, you're gonna state the properties of inverse function. Before we will start our lesson, let's have an activity. The activity is named Identify Rule. Instruction, you're going to identify whether the given situation is one-to-one function or not.
Let us now test your understanding. Answer the following items. Identify if the given is one-to-one or not. You may pause the video so you can answer these items. Let's check our work. First, it is one-to-one. Second, it is not because as we can see for 6, it has two x values paired with it. Next, it is one-to-one. And last, it is not because of 19 on y, it is paired with two values of x which are 9 and 8. How about this? Again, you may pause the video to answer the following items. Let's check it now. First, the function is one-to-one. Second, the function is not. Third, the function is one-to-one. First, it is not one-to-one. And the second, it is one-to-one. Were you able to answer all of the problems? If yes, great job.
What is inverse of one-to-one function?
So let us define inverse function. The inverse function undo what the function does. And remember, only one-to-one function has an inverse. Let f be a one-to-one function. Its inverse is denoted by this symbol, read as f inverse. A function f has an inverse if for every y in its range, there is only one value of x in its domain. In symbols, f inverse of y is equal to x, for which f of x is equal to y. Here are the steps in finding the inverse of a one-to-one function. Step 1. Replace f of x with y. Step 2. Interchange x and y variables. Step 3. Solve for y in terms of x. And step 4. Change y with f inverse of x. Let's have an example. Find the inverse of f of x equals 2x plus 1. Step 1 again, replace f of x with y. So we're going to replace f of x with y. So this will become y is equal to 2x plus 1. Step 2, interchange x and y variables. So our y will become x and our x will become y. So this will become x equals 2y plus 1. Step 3, solve for y in terms of x. To solve for y, let us move 1 to the other side. So this will become 2y is equal to x minus 1. And then we divide both sides by 2. This 2 will be cancelled out and we will be left with y is equal to x minus 1 over 2. And finally, let us replace y with f inverse of x. So f inverse of x is equal to x minus 1 all over 2. Let us have another one. Find the inverse of g of x equals x cubed minus 2 if it exists. Step 1. Replace g of x with y. So y is equal to x cubed minus 2. Step 2. Interchange x and y variables. Y will become x and x will become y. So x is equal to y cubed minus 2. Step 3. Solve for y in terms of x. To solve for y, let's move negative 2 to the other side. So it will become x plus 2 is equal to y cubed. And then let us extract the cube root of both sides. Cube root of y cubed is y. Then we simply have to copy this. So cube root of x plus 2 is equal to y. And finally, let us change y with g inverse of x. When we write our final answer, we write our g inverse of x on the left side. So g inverse of x is equal to cube root of x plus 2. Let us have another one. Find the inverse of p of x equals 5x plus 3 if it exists. Step 1. Replace p of x with y. So this will become y is equal to 5x plus 3. Step 2. Interchange x and y variables. So we have x is equal to 5y plus 3. Step 3. Solve for y in terms of x. To solve for y, let us move positive 3 to the other side. So this will become x minus 3 is equal to 5y. And then we divide both sides by 5. So 5 and 5 here will be cancelled out. So we have x minus 3 all over 5 is equal to y. And last step, let us change y with p inverse of x. Again, when we write p inverse of x, let's put it on the left side. So we have p inverse of x is equal to x minus 3 all over 5. Another one. Find the inverse of q of x equals 4x over 5 if it exists. Again, step 1, let us replace q of x with y. So y is equal to 4x over 5. And then step 2, interchange x and y variables. So we have x is equal to 4y over 5. Step 3, solve for y in terms of x. To solve for y, let us apply cross multiplication. So we have x times 5, that is 5x, equals 4y. And then we divide both sides by 4. So 4 and 4 here will be cancelled out, and we will be left with 5x over 4 is equal to y. And then we replace y with q inverse of x. So q inverse of x is equal to 5x over 4. Let us move to our second objective. Given a one-to-one function f of x and its inverse f inverse of x, the following holds true. Letter A, the inverse of f inverse of x is f of x. Letter B, f of f inverse of x is equal to x for all x in the domain of f inverse. And letter C, f inverse of f of x is equal to x for all x in the domain of f. Let us prove the first one. The inverse of f inverse of x is f of x. Let's have an example. F of x is equal to x plus 4. So let us recall the steps. First, let us replace f of x with y. So y is equal to x plus 4. Step 2, let us interchange x and y variables. So this will become x is equal to y plus 4. And then step 3, let us solve for y. So to solve for y, let us move 4 to the other side. So this will become y is equal to x minus 4. And then we replace y with f inverse of x. So f inverse of x is equal to x minus 4. Now we already have the inverse. What we are going to do next is to get the inverse of this. So the inverse of the inverse is f of x. So we are going to prove that when we get the inverse of our inverse, we will go back to the original function. So what is the inverse of f inverse of x? So let's start with our inverse, x minus 4. Let's follow the steps. First one, let us replace f inverse of x with y. So y is equal to x minus 4. Step 2, let us interchange the x and y variables. So x is equal to y minus 4. Then step 3, let us solve for y. To solve for y, let us move negative 4 to the other side. So this will become y is equal to x plus 4. But what is x plus 4? X plus 4 is actually our f of x. So it means after getting the inverse of the inverse, we return to our original function. Therefore, the inverse of f inverse of x is equal to f of x. Let us prove letter B. F of f inverse of x is equal to x for all x in the domain of f inverse. So let us recall our f of x as well as its inverse. Now we have f of f inverse of x. Let us copy f. Now f inverse of x, we already have that. That is x minus 4. So we have x minus 4. So this will be our x. So we have f of x. But f of x is equal to x plus 4. Now, this x here is equivalent to x minus 4. So we will replace this with x minus 4. So x minus 4, and then we copy plus 4. Negative 4 plus 4 will be cancelled out, so this will be equal to x. Therefore, f of f inverse of x is equal to x. Now let us prove letter C. F inverse of f of x is equal to x for all x in the domain of f. So let us recall our f of x and its inverse. Now we have f inverse of f of x. So let us copy first f inverse and then f of x. Our f of x is equal to x plus 4. So this will be of x plus 4. This time this will be our x. So we have f inverse of x. And f inverse of x is equivalent to x minus 4. But our x here is equal to x plus 4. So we are going to replace this with x plus 4. Then copy minus 4. So plus 4 minus 4 will be cancelled out. So this will be equal to x. Therefore, f inverse of f of x is equal to x. Let's have another example. F of x is equal to 3x. So let's follow the steps. Step 1, replace f of x with y. So y is equal to 3x. And then let us interchange the variables. X is equal to 3y. And then let us solve for y. To solve for y, let us divide both sides by 3. So 3 and 3 here will be cancelled out. So we have y is equal to x over 3. And then we replace y with f inverse of x. So f inverse of x is equal to x over 3. Now let us prove that the inverse of f inverse of x is equal to f of x. So we'll start with replacing our f inverse of x with y. So y is equal to x over 3. Then we interchange the variables. X is equal to y over 3. And then we solve for y. To solve for y, cross multiplication, x times 3 equals y, or y is equal to 3x. But 3x is actually our f of x. So we prove that the inverse of f inverse of x is equal to f of x. Letter B, let us prove that f of f inverse of x is equal to x. So we have f of f inverse of x. Let's copy f. Then f inverse of x, we already have that, and that is equal to x over 3. So this will now be our x. So we have f of x. But what is f of x? F of x is equal to 3x. So this will be equal to 3. And then our x is equivalent to x over 3. So 3 and 3 will be cancelled out. So we have f of f inverse of x is equal to x. Last one, letter C. F inverse of f of x is equal to x. So f inverse of f of x, let us copy f inverse. Our f of x is equal to 3x. So this time this will be our x. So we have f inverse of x. But f inverse of x is equal to x over 3. Our x here is equivalent to 3x. So we are going to replace this with 3x. So 3x over 3. 3 and 3 will be cancelled out. Therefore, f inverse of f of x is equal to x.
So how to graph an inverse function? Take note that in graphing an inverse function, it is just similar with how to graph any function. So here are the steps. First, identify its domain and range of the given one-to-one function. So finding the domain and range of one-to-one will be our guide in sketching the graph of one-to-one and the inverse function. So second, complete the table of values, then sketch the graph of one-to-one function on the Cartesian coordinate plane. Third, find the inverse function and determine the domain and range of the inverse by looking at the domain and range of one-to-one. Fourth, make the table of values for the inverse function. You may just simply interchange the x and f of x values from the one-to-one and then sketch the graph on the same plane. First example, sketch the graph of f of x is equal to 3x plus 1 and its inverse. In order to do this, let's follow the steps provided in the previous slide. So as we can see here, we have a linear function, and as we all know, the domain and range of a linear function are both sets of real numbers. So we have set of x such that x is an element of real number for the domain, and for the range, we have set of y such that y is an element of real number. Next step is to create a table of values, and in doing that, we can use any real number for x, and then we'll be able to find the values of f of x. Let's have 5 values, x and f of x, but actually you may have less than 5 or you may have more than that. It is up to you. Let's say we have -2, -1, 0, 1, and 2 as the values of x. So for the f of x values, again, substitute each x value to our function to find f of x. For an example, let x be -2. 3 times -2 gives us -6, plus 1 is -5. Next, we have -1 times 3 is -3, plus 1 gives us -2. And do the same procedure here. So if we have x equals 0, that's 1, x equals 1, that's 4, and x equals 2, that is 7. After having the table of values for our given function, let us now plot the points on our Cartesian coordinate plane. So if we have -2, it has -5 for f of x, -1, -2, 0, 1, 1, 4, and 2, 7. Next, let us connect these points. So here is the graph of f of x is equal to 3x plus 1. Since this is a linear function, we can extend the endpoints infinitely. Next is to find the inverse function of 3x plus 1. So for the inverse, we need to follow the 4 steps. We have y is equal to 3x plus 1. Interchange x and y. So we have x is equal to 3y plus 1. We need to solve for y, so isolate this. We have x minus 1 is equal to 3y. Divide both sides by 3. Cancel. Change y to f inverse of x is equal to x minus 1 over 3. So here is now our inverse. So again, for our inverse, we have x minus 1 over 3. And for the domain and range of this, we base it on the domain and range of our given function. Since it's linear, we have domain and range for this inverse as set of real numbers as well. As for the table of values, instead of plugging in values of x to our function and then solve for the value of f of x, we will just simply interchange the x and f of x from the previous function. So if you still remember the x and f of x, we have -5, -2, 1, 4, and 7 as the values of f of x. Okay, so here it will become the values of x, and then the values of x will become the values of f of x. So we have -2, -1, 0, 1, and 2. Let us now plot these points on our Cartesian coordinate plane. So we have -5, -2, it's here, -2, -1, 1, 0, 4, 1, and 7, 2. Okay, let's say this is 7 and here is 2. Next, we need to connect all the dots. Extend. Okay. So here is the graph of our inverse. And looking at these two graphs, okay, Let us see if they are symmetrical with respect to our identity function, wherein whatever x value you have. Now let us see if these two graphs are symmetrical with respect to the identity function y equals x. Let us now sketch the graph of our identity function, our basis of symmetrical. Now, look at our graphs. Are they symmetrical with respect to this? Yes or no? Imagine that you are flipping this Cartesian plane with respect to this diagonal line. Will they overlap? It's a yes. Okay, so this is how we sketch the graph of one-to-one and inverse. So in summary, we have the following information. So we have the domain and range of the given function. We also have the inverse and the domain and range. And we have their graphs. So for these graphs, I used GeoGebra, okay, to show to you the relationship of the given function 3x plus 1 and its inverse x minus 1 over 3. Let's have another example. Sketch the graph of f of x is equal to negative square root of x plus 2 and its inverse. So again, the first thing that we will do is to find the domain and range. So since it's radical, take note that there are values that are restricted for the radicand. Okay, again, the radicand cannot be negative. So for the domain, we need to do x plus 2 is greater than or equal to 0. So here we have set of x such that x is greater than or equal to negative 2. So as for the range, for every real number for x, there corresponds a value of y that is less than or equal to 0. Now let us create a table of values for this function. So we have x and f of x. Take note that the values of x should be greater than or equal to negative 2. So let's say we have negative 2, negative 1, 0, 1, and 2. To find the values of f of x, we need to plug in each x value to our function. So by doing that, we will be having 0, negative 1, negative 1.41, negative 1.73, and negative 2. So the next thing that we'll do is to plot all of these points. This portion can be extended going to the right because it says here x is greater than or equal to negative 2. But for this portion, we cannot. This is the starting point of the values of x, negative 2. Now, let us find the inverse of our function, negative square root of x plus 2. So for the inverse, we need to follow the same procedure. Change f of x to y. So negative square root of x plus 2. Next, interchange the variables. X is equal to negative square root of y plus 2. Since y is inside the radical, we need to take the square root of both sides. So we now have x squared is equal to what will happen here. Squared, cancel the radical. The square of negative becomes positive, so we have y plus 2. Next, isolate y, so we have x squared minus 2 equals y. And the inverse here is f inverse of x equals x squared minus 2. To make the table of values for this inverse function, we are not going to think of other values of x and f of x. Instead, we will just simply interchange the x and f of x of the given function. So here, we have 0, negative 1, negative 1.41, negative 1.73, and negative 2 as the values of x, and we have negative 2, negative 1, 0, 1, and 2 as the values of f of x. The next step is to plot all of these points. Next step is to plot all of these points. Now, let us identify what part of this inverse function needs to be extended. First, let us identify the domain of this function by using the range of the given function. So we have set of x such that x is less than or equal to 0. Okay, now as we can see in our domain, we have less than or equal to 0, meaning we have to start from 0, then goes left because of the symbol less than. So meaning to say, this portion of the graph cannot be extended going up or going down or going to the right, because this is the starting point of our domain and it goes left. So this is the portion of our graph that can be extended. Now, to check if these two are really symmetrical with respect to our identity function, let us draw the identity function now, y equals x. Let us use this as our guide. Let us see if they are symmetrical with respect to this line, y equals x. Imagine that you are flipping this Cartesian plane with respect to the diagonal line. Okay, will these two coincide? And the answer is yes. Okay, so they are really symmetrical. Now, for the range of this function, we base it on the domain of our f of x. That gives a set of y such that y is greater than or equal to -2. Is this really true on our graph? Yes, it is. From -2, then the graph goes upward continuously. Were you able to follow how to sketch the graph of 1-to-1 and its inverse function? I hope so. Now, after showing you how to sketch the graph of 1-to-1 and its inverse, it is now time to test your understanding. Do this activity. Graph the given function, then find the inverse and sketch its graph, then state their domain and range. You may pause the video so you could do this. In order for you to check if you did it right, you may use any graphing software to check your answers. So for this lesson, take note of the following. The graph of the function and its inverse are symmetric with respect to the line y equals x or the identity function. F of x and f inverse of x are like mirror images. So to sketch the graph of 1-to-1 and its inverse, you may follow the following steps.
Here is the summary of what we discussed. Now it is time to check your understanding. Pause this video for more time. Here are the answers. Keep on practicing to master the lesson.